Okay, ladies and gentlemen, let's talk about some simple probability. Now, simple probability is exactly what it says, the chances of something happening. Now, what we have is we have classical or theoretical probability. Classical or theoretical probability is easily defined as P of A, probability of A happening, equals the number of successes over the number possible or total. So for example, let's take this. Let's make a spinner. It has 6 pi wedges in our spinner. 1, 2, 3, 4, 5, 6. I want to find the probability of 2, which means I want to find the probability of getting a 2. So I only see 1, 2 in this spinner, so I'm going to say that's one option out of a total of 6. Now, I could say the probability of getting a 5. Well, that also would be just one option out of 6. Now, I could make it somewhat more complicated and find the probability of getting a 1 or a 2. If I want to get a probability of a 1 or a 2, now I have 1, 2 spots that would work. So that's going to be 2 out of 6, or we reduce it to 1/3. Let's get even a bit more creative than that. Let's see if we can get an even number. We'll see even number. That means I have a 2, a 4, and a 6. Those are all even. So that's 3 successes out of a total number of 6 possible, or 1/2. So simple probability really is just that. If, on the other hand, I had a die, standard 6-sided die, I have 1 here, 1, 2, 3 up here, 1, 2, 3, 4, 5 here. If I wanted the probability of getting a 4, probability of getting a 4, that would be 1 out of 6. There you go. If I had a 12-sided die, now good luck on having to try to draw a 12-sided die, but it would be a strange looking die like this that has all sorts of different faces on it, and they're all labeled with different numbers 1 through 12. So if I wanted to get the probability of a 3, now since there's only 1 3 on a 12-sided die, it'd be 1 out of 12. If I wanted the probability of a number from 1 through 5, well, let's see here. 1, 2, 3, 4, 5. That would be 5 options out of 12, and you get the idea. Another way to think about this, and another common application, is let's say I have a chart. I have classes A, B, C. And the number of students in those classes is 21, 25, and 32. My question is, what's the probability that you're in class A? Well, the question becomes, what are the number of successes? Well, there are 21 people in class A out of how many people? Well, now I need to figure out what the total is. And although there's 3 categories, I can't say out of 3, because how many people are here total? Well, 40, 70, looks like 78 people. So it'd be 21 out of 78 are my chances of being one of the people in class A. Now, if I want the probability of being in class A or B, now I would simply take these 2 and put them together, and I would have 46 out of 78. So I can do it from a chart. So whether it's a die, a spinner, a chart, we can begin looking at all of these. Let's look at one more probability though. I could have the probability of not probability of not being in class A. Well, I could do one of two things. I could either add the probability of B and C, so it'd be 57 out of 78. That would be not in class A. Or I could say that the probability of not A equals 1 minus the probability of being in Class A. So I have 1 minus, in Class A was 21 out of 78. Using common denominator, 78 over 78 minus 21 over 78 leaves me 57 over 78. So it works out just as well. So this is simple probability, and you can have some homework problems associated with this. It's not too bad. See what you can do with it.